This is the Algebra 1 Summer School video for Unit 2, Lesson 4, Graphing Linear Inequalities. This is the last lesson of Unit 2. It says here that a linear inequality in two variables looks just like the graph of a line, but sometimes it has a couple different things. It's going to have a shaded region, and sometimes we're going to use a dotted line. We'll explore what all these things are and what they look like throughout this lesson of notes. What we need to know is that a solution of an inequality is an ordered pair. It's a point that's on the grid that produces a true inequality statement. So for example, we're going to see if points are true or false, if they're solutions to certain inequalities. I know here, I'm trying to say is negative 6, 3, a solution of x plus y is greater than or equal to negative 3. In order to do that, I'm going to identify that negative 6 is x, and 3 is a y value. And I'm going to substitute those into the equation for x and then for y. So for x, when I do that, I end up with negative 6 plus 3. I want to know if that's greater than or equal to negative 3. Well, negative 6 plus 3 is negative 3. And negative 3 plus 3 is definitely equal to negative 3. So yes, that point is a solution to the inequality. I'm going to do the same thing on the right here. I want to know is 1, which is an x value, it's going to go in for x, is 1, 2 a solution to the same inequality? So I go ahead and I put 1 in for x and get 1 plus 2. I want to know, is that greater than or equal to negative 3? Well, 1 plus 2 is 3, and I would say that 3 is definitely greater than or equal to negative 3. So yes, both of those points are what we would call solutions to the inequality. Now, you might be wondering why we're going to do that. And in this unit, we're just going to be graphing inequalities. It's kind of a theoretical thing. We're just going to look at graphs. In the last unit of this course, Unit 7, we're going to do applications and word problems. So you're going to see why it's really important that we know what a solution is to an inequality. All right, so graphing a linear inequality is very similar to graphing a line. I am going to look at y equals mx plus b form. I'm going to make sure that my equation is solved for y. And then I'm going to graph it with the y-intercept and slope. The only difference about inequalities have to do with solid lines and dotted lines. If I have an inequality with an equals underneath, less than or equal or greater than or equal, I'm going to use a solid line. I'm going to use a dotted line for a strict inequality that's just greater than or less than. Then I'm going to shade. We'll talk about shading in just a second. So example 3 here, this inequality is already solved for y. So I can go ahead and graph my equation knowing that the slope is 4 and the y-intercept is negative 3. So if I go to negative 3, that's my y-intercept, and I'm going to go up 4 over 1. All right, 1, 2, 3, 4 over 1. Now when I connect those dots this time, because I have a strict inequality, I'm going to use a dotted dashed line. So the line this time is going to end up being dotted through those lines. It's not going to be solid. Now I need to shade. Every inequality is going to have a shaded region. For the greater than symbols, I'm going to shade above. For the less than symbols, I'm going to shade below. Well, what I have here is y is greater than 4x minus 3. So I need to shade above. Above this line is over here. So I'm going to end up shading that way. I don't have to color it in really carefully. I'm just going to scribble there that represents my shaded region. The final thing we need to do with these inequalities is figure out is 2, 5 in the solution set. So I'm going to look at 2, 5 right here. 2, 5 ends up being right on the line. Because the line is dotted, we're going to say that no, that point is not in the solution set. However, 0, 0 is fully in the shaded region. So yes, 0, 0 is a solution. It would make that inequality true if I substituted it into the equation. Okay, let's try another. So now I have the equation x plus y is less than or equal to 4. First thing I have to do is solve for y this time. So I'm going to draw my line down, and I'm going to subtract x from both sides. That gives me the inequality y is less than or equal to 4 minus x. I now have solved for y, and I can graph my equation because I know that the slope is negative 1, there's a 1 in front, and my y-intercept is 4. So when I start at 4, I have my slope of negative 1. That's an easy one to graph. Down 1 over 1 in both directions. Now I have a less than or equal to, which means when I make my line this time, it's going to be a solid line that connects all those dots. No, that gets confusing. Solid because we have the equals to right here. Now finally, that's a less than or equals to. So I end up having to shade below a line that I graphed. Now I'm trying to see, are the points 2, 2, and 1, 2 in the solution set? So when I look at 2, 2, that point is again on the line. But this time, because the line is solid, we say that that point is, yes, a solution. When I look at 1, 2, that point is also in the shaded region, so it is also a solution. 2 more. If you could graph lines in the last few lessons, you can graph these inequalities. You just have to remember to shade and when to use a dotted line. All right, in number 5, I need to solve this inequality for y. So I'm going to go ahead and start and subtract x from both sides. When I subtract x from both sides, I end up with negative 3y is greater than or equal to 12 minus x. Now, in order to get y by itself, I'm going to divide by negative 3. Every single term gets divided by negative 3. But here's the thing. You have to remember back to Unit 1. When I'm solving an inequality and I divide by a negative, I need to flip the sign. That's really important. My sign is now flipped around. And I have y is less than or equal to negative 4. Now here again, negative divided by negative is a plus x over 3. Lots of things to remember there. Negative divided by negative is positive. I have to flip the sign. But now I know that my slope is 1/3 and my y-intercept is negative 4. So it's nice and easy to go ahead and graph this line. I plot the y-intercept negative 4 and I go up 1 over 3. It's a positive slope. I'm going to go to the left here so that I get a nice graph across my whole grid. And I end up connecting those dots with a solid line because there's an equals to underneath of the inequality. All right, now I go ahead, I'm going to figure out where to shade. It says y is less than or equal to. So less than or equal to is down below. And I want to see, is 0, negative 4 in my solution set? Yes, that point is right on the line. And 0, 1 is no, because it is not in the shaded region. Okay, one more example of solve for y and graph, and then we're going to talk a little bit about the shading above and below, because that can get a little confusing. I have the line y is greater than 3. Now, first of all, there's no x. So even if I wanted to put this in y equals mx plus b form, I don't have an x, so I would have 0x plus 3. Well, that means then that my slope is 0 and my y-intercept is 3. That's a lot of work to remember that y greater than 3, that's a horizontal line. We talked about that earlier in this unit. That's a horizontal line that goes through 3 at the y-axis. because this is y is greater than without the equals to part, I have to put on a dotted line here, which didn't go exactly through the point I wanted it to. So let me try to move that right there. All right. Now I need to shade. Y is greater than 3, so I'm going to shade up above for greater than. I'm going to check the points. 3, 0 is right here. That is definitely not in the shaded region. And 6, 2 is also definitely not in the shaded region. It's not a solution. All right, 2 is not greater than 3, and neither is 0. All right, let's talk a little bit about shading, and then we'll be all set for this last set of notes of the unit. When I shaded linear inequality above the line, we use the greater than inequalities when I want to shade above. That's greater than or equal and greater than. Shading above is always higher than the line. So in this first example, shading higher than the line would be shading this region right here. The next example, shading higher, would be here. The horizontal line's really easy. Shading above is on the top, but this vertical line, I have to think about which x values are bigger. Well, it turns out all these ones on the right are bigger than their negative counterparts on the left, so that's shading above for greater. Shading below uses the inequalities less than or equal to and less than. So below is always underneath the line. So I'm going to shade the lower region of every graph. The slanted lines are pretty easy, and so is the horizontal. Below for a vertical means I'm going to shade where the smaller numbers are. So that's usually where the negatives happen to be. Okay. Now I have one more problem on these notes. This is an OST style question. Okay. For this OST style question, it says a system of inequalities is shown. We haven't talked about systems, but we do know about graphing linear inequalities. So first of all, it says use the add arrow tool to graph the boundary lines of the system. I don't have this computerized program of this, but the add arrow tool is this guy right here. Basically that means graph the lines. So you need to know y is greater than or equal to 5. We just talked about this. That's a horizontal line that goes through y equals 5. Now it's going to end up having a solid line because y is greater than or equal to 5. Oops, I have a dotted line selected. So I would select y equals 5 and y is greater than or equal to. So I'm going to shade above that line. Now I have one more line that happens to be in slope-intercept form. So I have m here of 2/3 and the y-intercept of 3. It's already a y-intercept form, so I only have to graph this line just as simply as I thought. So I start at 3, I go up 2/3 for my slope in both directions. That inequality also gets a solid line because it is less than or equal to. So I'm going to go ahead and graph that line. Now I have to shade for this line as well. Y is less than or equal to, which means I'm going to shade below here. Now you might be wondering, well, I just graphed 2 inequalities. I need to find, it says place a star on the coordinate plane to show a solution to the system. Well, what actually happens is the solution to the system is the shaded region where both colors overlap, which is right here, where both shaded regions overlap. So even though those other parts are solutions, they're not solutions to the system. So you can leave them on your paper. I'm just going to erase so that we can see more clearly. Then it says we would add star, which means you would go in here and you would place a point somewhere in that shaded region. That didn't turn out too well. Somewhere in that shaded region right there, we'd put a star. Right, that would be a solution. All right, so that's an application for an OST style question of graphing linear inequalities. Go back to Canvas, do the practice as your last practice of the unit, then you'll be all set to take the unit test.